Anytime you have two or more variables in an equation, you have a mathematical relationship. And for example, let me give you an equation of a circle. You just studied circles, so let's look at this one. X squared plus y squared equals to 169. So what is that? That represents a circle with a center at the origin and a radius of 13. 13 is the exact square root of 169. Now, if you were to represent all the pairs and numbers that fit into this relationship and plot those on a graph, then that's how we get this circle. And so the circle represents the total collection of all the relationships between x and y in this equation. Well, in this chapter, we're interested in studying mathematical functions, and functions are a special form of mathematical relationship. And what distinguishes a function from all other relationships is that functions, for every input value, there's a single output value at most. And now, for purposes of this course, in this chapter, we're going to look at x values as inputs and y values as outputs. Matter of fact, when we graph, the horizontal axis, which in an algebra course is usually x and y, I mean this is x and vertical is y, the horizontal axis is often called the independent variable or the input variable, and the vertical axis is the dependent variable or output variable. So anyway, we're treating x as input and y as output. Now, it turns out this relationship is not a function, and so I'm going to start off by showing you something that's not a function, and then we'll demonstrate something that is a function. And by looking at the graphs, it also allows me to show you that distinction graphically, because there is a very clear-cut difference between functions and non-functions in terms of their graphs. So, all right. So suppose that we had an x value of 5 as our input. If input is 5, what's the output? Well, 5 squared plus y squared equals 169. You can do the math there, and you can find that 12 is a valid output. 5 squared plus 12 squared equals 13 squared. But also, so is negative 12. So I could have the same input of 5, but two separate outputs. So let's see what that means in terms of a graph. So here's my circle with radius 13, center at the origin. And I'll try to make it look a little more like a circle. That's a little better, I guess. So if we go to 5 on the x-axis and travel upwards vertically, then we bump into a point on the circle. And that point is 5, 12. And then if we go down vertically from our input value 5, then we have another point on the graph, which of course is 5, negative 12. So you see these numbers on the x-axis serve as inputs, and wherever they map to points either above or below on the circle. These are the outputs. The output is either 12 or negative 12. So this for this one input, has two outputs. And now this sort of sets up something called the vertical line test, which I'll recap when we get to the end of this video. But basically, if you can draw a line through a graph, and if that line hits the graph in 2 or more places, then you don't have a function. It's a relationship that's not a function. All right, so here's an example of non-function. And now I'm going to give you an example of a function. So I'll erase the board and we'll put one up. Here's my new equation. Y equals to x to the third power minus 9x, or you might call it x cubed minus 9x. It's a third degree polynomial equation or function, And we're going to study those in a later chapter, study polynomials. And there's some nice patterns that you'll learn about. So at the moment I can't expect you to graph that accurately, but I'm going to sketch the graph for you.